Hello everyone. In this session of CCNA series, I will discuss DHCP snooping. DHCP servers are essential in today's networks, with practically every user endpoint relying on DHCP to learn its IP address, mask, default gateway, and DNS IP addresses. DHCP, also known as Dynamic Host Configuration Protocol, is a network management protocol used to assign IP addresses, used to automatically assign IP addresses and other network configuration parameters to devices on a network, which allows them to communicate with other devices on an IP network. So, multiple DHCP servers can be used in large network to provide redundancy or load sharing. So when a DHCP enabled client needs an IP address, it broadcasts a discover message. So DHCP server that receives the discover message will respond with an offer message, and so on. It completes the DORA process. So the client selects one of them based on the first DHCP offer message it receives. So imagine an attacker decides to disrupt the network and steal sensitive information by, for example, using DHCP spoofing. The attacker would connect a laptop or a small network appliance to an available network port. Then configure the device to run as a rogue DHCP server. The rogue DHCP server starts listening for DHCP discover message from clients trying to connect to the network. So when a legitimate client sends out a discover message, both the legitimate DHCP server as well as rogue DHCP server responds with an offer message. So the client receives both the offer message, I mean from DHCP servers, legitimate as well as rogue, but may accept the offer from the rogue server if it arrives first or due to any other reason like network latency. So the attacker might be smart enough to place the DHCP server, rogue DHCP server, in such a place that the client will receive his offer message first. So once it receives the offer message, the rogue DHCP server assigns the client an IP address from its own pool so that the traffic should be diverted to his server. So the client unknowingly accepts this configuration and starts sending the network traffic to the attacker device. The attacker can now perform various malicious activities such as man in the middle attack, traffic redirection, or network disruption. So now let's look at some of the DHCP snooping concepts. So DHCP snooping is a security feature designed to protect DHCP infrastructure from such malicious or malformed DHCP traffic which we discussed. With DHCP snooping enabled, the network device would block DHCP offers from this untrusted source, ensuring network stability and security. The main purpose of DHCP snooping is to prevent unauthorized or rogue DHCP server from disrupting IP addresses. Distributing IP addresses and network configuration data, which can lead to network issues or security vulnerabilities. DHCP snooping ensures that only trusted DHCP server can assign IP addresses in the network. On a switch, I would say it acts like a firewall or a ACL. So DHCP snooping generally classifies, let's see how DHCP snooping works. DHCP snooping generally classifies interfaces into two categories: trusted and untrusted. Trusted ports are interfaces that are allowed to send DHCP server messages. Typically, these are ports connected to legitimate DHCP servers or to other network devices that can be trusted to relay DHCP messages, such as another switch with DHCP snooping configured. Untrusted ports are interfaces connected to client devices. these ports are not allowed to send a DHCP server message. So if the DHCP snooping is initiated, the DHCP offer message can only be sent through the trusted port. Otherwise, it will be dropped. So when a DHCP request comes, the trusted port can only accept the DHCP offer message. If you look on the left, I have a trusted port where a legitimate DHCP server is connected, and on the right, where I have a rogue DHCP server connected. So when a DHCP offer comes, it blocks it. So DHCP snooping works by creating a DHCP snooping binding table that records information about the IP addresses assigned by the trusted DHCP server. So it records the IP addresses assigned to the clients. It monitors DHCP. It also monitors DHCP filter messages. DHCP messages and filters out any that comes from the untrusted sources. So with that, what I mean is, like for example, on the left, if you see, it's a trusted port. All the DHCP messages are approved. On the right, if you see, I have an untrusted port. Okay. So any DHCP server messages are discarded if it is initiated by client connected to this port. Or for client, actually it blocks all the server messages. Any messages from the DHCP server, it blocks. For messages from the client, we have, like for example, discover and request message, right? It checks for MAC address consistency between the Ethernet frame and DHCP message for discover and request message. It filters it based on MAC address. Whereas for release or decline messages, it checks the incoming interface plus IP address versus the DHCP snooping binding table. We will discuss about this in the upcoming slides. For leased messages, it builds a new entry to the DHCP snooping binding table. So let's see how it does filtering, how it filters discover messages based on MAC address. Actually, it does one simple check where it compares the CH address in DHCP packet with the source MAC address in the Ethernet frame. CH address actually is a client hardware address field used by DHCP discover message to identify the client. So when an attacker attempts to lease all the subnet addresses by overloading the DHCP server, it uses fake MAC address A in the Ethernet field and different CH address values in the discover field. So from a DHCP standpoint, each message seems to be from a separate client or separate DHCP request. The attacker can attempt to lease every IP address in the subnet so that no other host could obtain a lease. DHCP snooping defeats this type of attack on untrusted ports. It compares the Ethernet header source MAC address to the MAC address in the DHCP header. If the address does not match, the message is discarded. So this way you can block if there is an attack from the client side as well. Let's see how it filters messages that releases IP address. You might have an attacker who would release the IP address before you release them, and then your device becomes unreachable. So let's just take a simple network. A DHCP client on the right leases IP address 172.2.101 from DHCP server on the left. DHCP snooping creates binding table for this flow. Okay, 172.16.2.101 is assigned by DHCP server on G103. However, if an attacker sends a DHCP release message before, like what I said is, there is an attacker connected to GI105, and if he sends a DHCP release message before the client lease expires, the address may be returned to the pool. And then attacker could then immediately try to lease that address, hoping that server assigns the same address to the attacker. But the one with DHCP snooping enabled, the switch compares the incoming message uh, and the incoming interface and tries to match the table entry. If the details are already available in the binding table, then it discards the release message from the attacker. So this is how it protects the leased IP. Here, if you see, the incoming message is a DHCP release message in port 105 listing address 172.16.2.101, which is assigned to the client. The DHCP snooping binding table lists 172.16.2.101 as being originally leased via message arriving on port G103. So, since it is available in the binding table, DHCP snooping discards the DHCP release message from the attacker. This is how it safeguards the assigned IP address. That's it for this session. I hope this was informative for you. Thank you for watching.